Let's go to page 40. Let's go to page 42. So on Tuesday, we stopped at the free body diagram. Now, and I've explained the question, and so the question is asking if this color is in equilibrium. So what is the relationship between beta, WK, and L? Oh, sorry. You need to write down the relationship between beta, WK, and L. Now, and on Tuesday, we have drawn the free body diagram, and we have four forces, and the collar itself has weight of W, and because it is on a rod that the collar can move to up and down, but it cannot move left and right. So we have a force going to the right out. Of course, you can write it. Of course, you can draw it like this, and this is also okay. Now, and because the collar cannot rotate, the collar can move up and down, but it cannot move to the left and to the right, and it cannot rotate. So it has a moment M here. Of course, we after calculation we know M equal to 0, but this is another story. But in the free body diagram, you need to mark this. Okay? You need to mark this. And then we have the spring. The spring will have a force. Will have a force T in this direction, in the direction of beta, because this angle is beta. Now, and then by equilibrium, we know F is equal to T plus R plus W. And what is the relationship we want to know? Now we have, here we have T, R, and W. And here we have, we have T, R, and W. And here we have beta, WK, and L. Let me repeat here, beta, W, K, and L. And of course, we have W here. Now, the question remains about these three. Because now we have T and R, but we don't have T and R here. We have beta, K, and L. Right? And in here, we have T and R. So how do we match these two together? How do we match these two? And from high school physics, we know one thing. And what is the magnitude of T? From high school physics, we have learned Hooke's law. So what's Hooke's law? F equals to what? Kx, good. Now, and here F equals to Kx, so this K is actually this K. Well, X is the change of length, right? Or we call elongation. This one. This is sorry. So in here, I would say, can I change it into K delta? T is equal to K delta. Anything that I should write more clear. So press them down because I'll go back a bit in a minute. So take your time to write them down. Oh, okay, take the time. And after you have written this down, please think about how should we write this? How should we write this? Okay, I will come back to this part in a minute. So let's go back to the question. And spring elongation is the length now minus the original length, right? Or the length of the spring now minus the original length. So, and of course you can write the length of the spring now, right? The length, because this distance is L and the length of spring now is L over cosine theta. Is that okay? Because this is L, and this is theta, and of course we have the spring. The length of spring now is L over cosine theta. So what is the original length of the spring? L, because the question says the spring is unstretched. The spring is unstretched when theta equal to 0. So the original length is here. Originally, we found the spring, we found the base of the collar, it is here. So original length is L. Okay. Now we know this thing. Now we go back to here, and so this one is because delta is this thing. Because delta is this thing, so T is equal to K L 1 over cosine theta minus 1. Now, if we know, so in this from this equation, what do, and then we compare this with this. you can see that we now have beta, and we have K, and we have L as well, right? So we have everything here. The last question is how to put them together. And now we go to the so we can from because we can take this equation, and because this equation is actually there are two equations here. Summation f equal to 0. Actually, we have two equations here. This summation fx equal to 0 and summation fy equal to 0. Now, and of course, you can try different strings, but I am using this one. I'm using summation fy equal to 0. Of course, you can try using fx equal to 0. You will get the same results. But I'm using this one. I'm using summation fy equal to 0. I'm using fy equal to 0. If we have fy equal to 0, it means t sine theta minus w equal to 0, because w is going down and t is going up, so we have t sine theta minus w equal to 0. Or then we know we have w here, and for theta, k, and l, we simply put this into here. So we have k, l 1 over cosine theta minus 1 times sine theta minus w equals to 0. Of course, you can stop. You can put this. You can say this is the answer. But I will make it this way. And you go to the make it look better. And this is the final result.